Induction is the process by which a charged object can use a separation of charges in a nearby object without directly touching it. This can happen through electromagnetic induction or electrostatic induction. Electromagnetic induction, when a conductor like a wire is placed in changing magnetic fields and it causes electrons in the conductor to move. It creates like an electric current. It's usually used in like generators and transformers. And electrostatic induction is a charged object brought near a neutral conductor that causes electrons within the conductor to move. If the object is negatively charged, it repels the electrons in the conductor, causing them to move away and leaving the side of the conductor closest to the charged object positively charged. Conversely, if the charged object is positively charged, it will attract electrons in the conductor, causing them to move towards the charged object and making the side of the conductor closest to the charged object negatively charged. So basically, electrons move during induction. Electrons are negatively charged, and if the object inducing the charge is negatively charged, electrons move away from the object in the conductor. But if the object inducing the charge are positively charged, electrons move towards the object in the conductor. And my example will be this relay. As you can see, it is using a magnetic field in the relay to create electromagnetic induction. So basically, whenever I turn the switch on the car, it creates electricity and sends like a signal to the fuel pump, basically causing it to make that sound. It pressurizes it so that whenever I turn it on to start it, it has enough fuel to start up right away, instead of taking a while to pressurize that gas. As you can see, if it was turned off, which it is now, it would just, but whenever it is on and it's working, it turns on right away.
Okay, I am going to show conduction, and conduction is thermal heat energy that transfers from two different objects that have different temperatures and create thermal energy. So water, boiling water, and the stove is the hot part, so it's heating up the water, making it boil, which was cool, and it is transferring thermal energy to this handle, so it's getting hot, and the water will soon start boiling.
Sometimes you may ask yourself, what is grounding? Grounding is basically known as earthing. It's the process of transferring excess charge from an object to the earth, which can absorb an unlimited amount of charge. Grounding is, literally the process of transferring excess electrons from an object to the earth, which can absorb unlimited amount of charge. This is done to neutralize the object, making it electrically neutral. Electrons are negatively charged particles that move during grounding. When an object is negatively charged, means like having excess electrons. Grounding provides a pathway for these excess electrons to flow from the object into the earth, neutralizing the object's charge. Conversely, if an object is positively charged, having a deficit means having a deficit in electrons, like having a low amount of electrons. Grounding allows electrons to flow from the earth into the object to neutralize the charge. In summary, electrons move during grounding. Electrons are negatively charged. If the object is negatively charged, electrons move from the object to the earth. And on the otherwise, if the object is positively charged, electrons move from the earth to the object. Basically, before I show you the example with the horn, I'm going to be showing you an example with a voltmeter. As you could see, right now the voltmeter is reading absolutely nothing. And if I were to put the voltmeter on just a regular positive, it would obviously read nothing because it's grounding to nothing. It's just flowing electrons. But once I ground it to somewhere where a bolt connects to bare metal to the chassis, now, and voila, it reads 11.82. That's how much volts. That's one of the grounding, and that button that you see that's lighted up is the other example of grounding. Right now, it is on. If it were grounded, it would be making noise. But since it's only flowing positive electrons, it's not grounding to anything. Therefore, it's not making any noise. But as soon as I touch it on the ground, obviously. Now, the reason I had to run a wire through this is because the horns, usually whenever they're mounted on, they already come with a ground. Once you connect it, it basically is touching ground all the time. All you need is a switch. But and that's basically how it works.